Have you ever wondered how some companies just seem to know what you're going to buy next? Or how scientists can predict these incredibly complex trends? You might think it's some kind of magic, but it's not. It's data science, and it's not a mysterious black box either. It's actually a structured process, a step-by-step journey that anyone can understand, a journey that takes us from a question to a powerful, data-driven answer. So let's go on that journey together.
So here it is. This is our roadmap. Every single data science project, big or small, pretty much follows these 6 core steps. You start with a goal, then you get your hands on the data, you clean it up, you explore it to see what's there, you build a model, and finally, you share what you found. This is the playbook that guides us from start to finish.
All right, for our expedition today, we're going to start with the most important part, figuring out the big question. Then, we'll dive into how you take messy, raw data and turn it into something you can actually use. After that, we'll go hunting for hidden patterns, use those patterns to try and predict the future, and finally, we'll cover how to tell the story that your data is trying to tell you.
Okay, first stop. And honestly, this might be the most important part of the entire process. Because here's the secret. A great data project doesn't start with data. It starts with a great question.
Seriously, before you even think about writing a line of code, you have to nail this down. What are we really trying to do here? Why does this matter to the business? And what are we going to do with the answer once we have it? I can't tell you how many projects fail because they brilliantly solve the completely wrong problem. This first step is your insurance policy against that.
So, the best way to get this all locked down is with something called a project charter. As you can see, this isn't just some vague idea, it's a concrete plan. It's a checklist. It clearly defines the goal, gives everyone the context, lists out the resources you'll need, and even spells out what success looks like and when it's due. This document gets everyone, from the tech folks to the business leaders, all nodding in agreement before the real work even starts.
All right, with our mission defined, it's time to gather our supplies. This means we've got to find the data we need and get it ready for the real analysis.
There is a classic saying in the world of data, and it is the absolute gospel for this phase. Garbage in, garbage out. You could have the smartest, most powerful model on the planet, but if you feed it junk data, you're going to get junk results. Period. The success of the entire project really hinges on the quality of the data you start with.
Now this might blow your mind. Data scientists can spend up to 80% of their time on this one step. Yeah, think about that. 80%. Not building cool futuristic models, but just cleaning, correcting, and preparing data. That tells you everything you need to know about how critical and, frankly, how time-consuming this stage really is.
So what does this data garbage actually look like in the wild? Well, here are a few classic examples. You've got your simple typos, impossible entries like a person who's 299 years old, or things a human would ignore like inconsistent capitalization. To a computer, Brazil and Brazil are 2 totally different countries. Even an extra space at the end of a word can break everything. These are the little gremlins that data scientists spend most of their time hunting down. You know, data almost never lives in one nice, neat file. It's usually scattered all over the place. So a big part of preparation is combining it. You can join tables, which is kind of like adding a new column of info to your data set, say adding a customer state to their purchase record. Or you can append tables, which is like stacking them on top of each other, like taking January sales and plopping February sales right underneath to make one long list.
Now that our data is clean and all in one place, we can finally get to the really fun part, exploration. Think of this like being an explorer entering a new land. We're not building a city yet, we're just drawing the map, trying to understand the landscape.
The goal here is not to find the final answer. It's to get a deep, intuitive feel for the data. We're on the lookout for patterns, for relationships between different pieces of information, and for anything that just looks weird. It's all about building your gut feeling for what the data is trying to tell you.
And to draw our map, we use a whole toolkit of pictures. We've got bar charts to compare things, line plots to see trends over time, and scatter plots to see if 2 things might be connected. Every single chart is like a different lens, giving us a new way to see the story in the data.
For instance, a super simple histogram can instantly show you the age breakdown of your customers. Are they mostly young? Is there an even spread across all ages? A single glance at this one chart can teach you so much about your data.
Okay, so we've mapped the terrain. We understand the landscape. Those patterns we just found, they become the foundation for our next step. It's time to build the solution. This is the modeling phase.
the part where we try to predict the future.
This is the moment of creation. We take our beautiful, clean, explored data and we feed it to machine learning algorithms to build a model. Maybe it's a regression model to predict a number, like next month's sales, or maybe it's a classification model that predicts a category, like is this email spam or not spam. The whole point is to build a tool that solves that big business problem we defined way back at the start.
But how do we know if our new model is any good? Well, you can't test it on the same data you used to build it. That's like giving it an open book test. It's cheating. So instead, we hold back a chunk of our data, maybe 20%, and we don't let the model see it. We train our model on the 80%, and then we unleash it on that hidden 20%. That's the real final exam.
And if you're wondering what a model is really doing, this picture is a perfect, simple visual. In a basic linear regression, the algorithm is just trying to find the single best straight line that it can draw through all those scattered data points. Its job is to cut through all the noise and find the real trend underneath. Now, after you run a model, you'll get an output that looks, well, a little intimidating, like this. But don't worry, you don't need to understand every number here. The key takeaway is that this summary tells us two main things. One, how accurate are our predictions? And two, which factors are the most important drivers of that prediction? For models that sort things into buckets, like our spam filter example, we use a tool called a confusion matrix. The name is a little ironic because it's actually designed to make things super clear. Think of it as a simple report card for our model. It shows you exactly how many predictions it got right, how many it got wrong, and even how it was wrong. So we've built the model, we've got our results, we're done, right? Nope. The journey is not over. A brilliant discovery is totally useless if it stays locked away in a data scientist's notebook. Now we have to share the treasure. This final stage really has two key parts. First, you have to present your findings in a way that's clear and compelling, a way that makes people want to take action. And second, if the analysis is valuable, you want to automate it so that the process can run again and again, delivering value over and over without you having to lift a finger. And this brings us to one of the most underrated truths of data science. Your ability to communicate and persuade is just as important as your technical skills. All of that complex analysis means absolutely nothing if you can't tell a compelling story with the data, a story that inspires people to make smarter decisions. So there you have it, a structured 6-step journey that takes you from a simple question to a powerful insight. This process is the framework for finding answers hidden in data. Which really just leaves one last thing to think about. Now that you know the process, what's the first big question you would ask?